Let's get started on part 2 of chapter 3. In this section we will be talking about volume types. In the previous section we talked about a simple volume which only goes on a single disk. In this section we will look at spanned, RAID level 0, 1, and 5 volumes. RAID stands for Redundant Array of Integrated Disk Drives, and all 4 of these volume types occupy more than a single disk. A simple volume on a basic disk occupies a single disk. That's a simple volume, which we did in the last section. But let's look at disk spanning and when we might need it. Here's the example. We have a 175 gig database file, and we have a server which has a 75 gig hard disk and a 75 gig hard disk and a 100 gig hard disk, and no one of those hard disks is big enough to contain the 75 gig database file. So what we do is we implement spanning. Spanning is where we take the D drive and we span it across 2 physical hard drives. And what that does is it creates a single logical D drive, which is 175 gig in size. The operating system sees it as a single D drive, which is 175 gig in size. So the reason we use spanning is to logically combine 2 physical hard disks to create a larger hard disk. Notice that these 2 hard disks can be different sizes. Now let's look at disk striping, RAID level 0, which is used to increase performance. If we look at disk striping, the D drive is stretched across 2 physical hard disks, and that looks like spanning, but the big difference is that with striping, the operating system writes to both hard disks simultaneously, which is a lot faster. It takes the 8 bits in a byte. 4 bits go to this disk and 4 bits go to this disk, and it increases performance, in this example, by a factor of 2. You can stripe across 2 hard disks if you want. You can stripe across 8 hard disks if you want, in which case it's 8 times faster. Of the 8-bit byte, each bit is written to a separate hard disk simultaneously, and that increases speed by a factor of 8. That's called a stripe set. Now, RAID level 1 is what they call disk mirroring. Remember, RAID stands for Redundant Array of Integrated Disk Drives. And in mirroring, a user at a workstation would save a file to the hard disk on a server, and the user doesn't know it, but actually that file immediately gets copied to another hard disk, another mirrored hard disk. So if either hard disk crashes, that's okay. We have the other one. Disk mirroring provides fault tolerance. RAID level 1 gives increased performance. RAID level 0 gives increased performance. RAID level 1 provides fault tolerance. Which one's better? Depends what you need. If you need it to be fast, RAID level 0. If you need fault tolerance, RAID level 1. So let's create striped and mirrored volumes on our server. But before we do, we have to convert the disk to a dynamic disk. The reason we convert a disk to a dynamic disk is because that's required to implement disk mirroring or disk striping. So notice disk 1 and disk 2 are just basic disks, and I want to mirror or stripe disk 1 to disk 2. We're not working on disk 0. Disk 0 has the operating system. We're leaving that alone. We're talking about the disks with data on them. So I will right-click on disk number 1 and select Convert to Dynamic Disk. I will select disks 1 and disk 2, but I will not select disk number 0 because that's not going to be part of the mirrored or striped set. I click on OK, and I will select disk 1 and disk 2, click on Convert. Then it gives me an error message that says if you do this, if you convert this disk to dynamic disk, you will not be able to start other installed operating systems which might be on this disk. Many of you have Windows 7 installed in the first partition on your hard disk and Windows 2012 Server on the second partition on the hard disk, and if you click on yes here, you will be able to boot to Windows 2012 Server, but you will no longer be able to boot to Windows 7. Is that a problem for me? Well, no, because I'm not doing anything to my C drive, which has the operating system on it. I am just doing it to the data disks, which don't have any operating systems on it, so that's not a problem. So I will click on OK. And you can see that disk 1 and disk 2 have now been converted to dynamic. Now I can do the mirroring or striping. If I right-click on my disk, I can select New Striped Volume. I click on New Striped Volume, and it says the striped volume stores data in stripes on 2 or more disks. A striped volume gives you faster access to your data. I click on Next. I select the disks that I want to be part of the stripe set, disks 1 and 2, not disk 0, and I click on Next. I accept the next available drive letter, followed by Next, and we typically format it as NTFS. I will give it a volume and a volume label, and I will call it data volume. I click on Next, I click on Finish, and now you can see that the E drive is striped across 2 10 gig disks. The logical E drive is striped across 2 10 gig disks. Now, if I look at it from the user's point of view, and I look at the Windows Explorer, there's the new E drive. And if I look at the properties, it shows that it's 20 gig in size. The user cannot tell that this E volume actually is striped across 2 10 gig disks. The user doesn't know. The user doesn't care. The single E volume appears as a 20 gig disk. Now let's look at mirroring. I will mirror disk 1 to disk 2 for the purposes of fault tolerance. I go to my first disk and I right click on it and I select Mirror New Volume. I click on Mirror New Volume and it says, where do you want to mirror it to? And I say, well, I want to mirror it to disk number 2. So I click on Add Mirror. Then it says, if you do this, it's going to create the disk to a dynamic disk, and if you do that, you won't be able to start other installed operating systems. Are you sure? And yes, I am sure. So I click on Yes, and then that mirrors disk number 1 to disk number 2. Now, mirroring means it copies the entire contents of disk number 1 to disk number 2. So it can take a little while for the disks to sync up depending upon the size of the disks. Okay, now they are synced up and the mirrored volume has been created. I have mirrored one 10 gig disk to another 10 gig disk, and it has the label of the E drive. So if I look at it from the user's point of view, I can then see that there is, it looks like an E drive, and that is made up of two 10 gig disks. But wait a minute, it says the total storage capacity is 10 gig. I thought it was made up of two 10 gig disks. It is. One 10 gig disk is mirrored to the other for a total storage capacity of 10 gig. If I striped across two 10 gig disks, then I would get a total storage capacity of 20 gig. But when it's mirroring, in this example, it's 10 gig. RAID level 0 gives increased performance. RAID level 1 gives fault tolerance. What if I want both? Well, I could use RAID level 5, because RAID level 5 does provide fault tolerance and increased performance, but it takes more disks and it's kind of complicated. So let's look at RAID level 5. RAID level 5 uses a stripe set with parity. Well, you already know what a stripe set is. A stripe set allows the operating system to write to multiple disks simultaneously for increased performance. But then it adds a ninth disk, what they call a parity disk, for purposes of fault tolerance. So what is a parity disk? To understand what a parity disk is in RAID level 5, it's important to understand the concept of parity. So let's look at the concept of parity. Parity is not used only on hard disks, it's also used on communication between two computers. So if one computer is sending the number 7 to another computer, the number 7 is encoded in binary as 5 zeros and 3 ones. The source computer sends 8 bits to the destination computer. Well, what if one of those bits gets accidentally flipped in transmission? Well, then the destination computer is not going to know that there's been an error in transmission. How can the destination computer know there's been an error in transmission? That's the purpose of using parity. What we have is the 8 bits which include our data, and we add a 9th bit for error checking. What we do is we add a 9th bit, and that 9th bit is called the parity bit. And then the 9th bit can be set to 0 or 1. And it is set to 0 or 1 such that when all of the ones are added up, the number of ones is an even number. So, if one of these bits gets accidentally flipped in transmission, and the receiving computer receives an odd number of ones, then it knows there's been an error in transmission, and it sends a negative acknowledgement to the sender. That's what parity is for, to identify errors in transmission. Similarly, RAID level 5 uses a stripe set with parity. Now you already know what the stripe set is. A 9th disk is added, and that 9th disk contains the parity bit, which is used for error checking. Remember, parity bit is always set to 0 or 1, such that when you add up all of the ones together, you get an even number of ones. So what if one disk goes bad? Well, you can put in a new disk and regenerate, but when the operating system regenerates, how does it know what's supposed to be on that disk? Is it supposed to be a 0 or a 1? Well, remember, with parity, we're always supposed to have an even number of ones. Therefore, when it generates that disk, it knows to make the bit on that disk a 1. The regeneration of a failed disk is based upon parity. And RAID level 5 is a stripe set with parity, increased performance, and fault tolerance, but it can be a little confusing. A stripe set can contain 9 disks, but the minimum number of disks in a stripe set is 3. And then if we consider the system volume, which is not part of the stripe set, then a computer which has a stripe set with parity will have a minimum of 4 disks, a minimum of 4 disks. I mean, on the other hand, it could have 10. You could have 8 disks in the stripe set, a 9 for the parity disk, and the 10th disk would be the operating system. But the minimum for a stripe set with parity is 4 disks. So here is how you do it. First, you have to put in at least 3 additional disks beyond the system volume. So here's what we do. Disk 0 has got the operating system on it, and we want the stripe set to be across disks 1, 2, and 3. So I select the first disk, I right-click, and I select New RAID 5 Volume. A RAID 5 volume stores data in stripes on 3 or more disks. It provides a way of recovering data if part of the data is lost. I click on Next, and I specify that disks 1, 2, and 3 will be part of the stripe set. I then click on Next. I will accept the next available drive letter, which is the E drive, followed by Next. We typically format it as NTFS, followed by Next, and then when I click on Finish, it begins to build the stripe set. But it takes a couple minutes for the stripe set to be constructed, because all of these disks have to work in sync with each other, and they're syncing up right now. And the bigger the disks are, the longer it takes. Now you can see that these 3 physical disks are combined into one stripe set with the drive letter E. Now, from the user's point of view, if the user then looks at that new E drive, the user can't tell that it's actually 3 physical disks combined into one. From the user's point of view, the user sees the E and thinks it's 1 disk. But actually it's 3 disks with a total capacity of 20 gig. That's 3 10 gig disks. 2 disks are data disks, and 1 disk is the parity disk. RAID level 0 is a stripe set. It's faster. RAID level 1 is mirroring. It provides fault tolerance. And RAID level 5, stripe set with parity, provides increased performance and provides fault tolerance. Let's now discuss selecting a partition style. And we previously discussed that MBR is the default partition style, but there's another partition style called GPT. Now, if we review the initialization of a disk, when we put in a new disk, we right-click and we select Initialize Disk. And we selected use the following partition style, MBR, which is Master Boot Record. Master Boot Record is the default partition style. You can select GPT, which stands for Globally Unique Identifier Partition Table, but notice the GP partition table is not recognized by all versions of Windows. In other words, no backward compatibility. If I select GPT, then it will convert the disk to a GPT disk. Why would I want to do that? The default Master Boot Record supports a maximum partition size of 2 terabytes, and for small servers that's fine. But larger servers need partition sizes larger than 2 terabytes. That's why we convert to GPT. GPT gives us a maximum partition size of 18 exabytes. An exabyte is 1 followed by 18 zeros. So an 18 exabyte partition is a pretty big partition. And they don't even make disks that are that big, but when they do, Microsoft will be ready. And a GPT disk can also be chopped into 128 partitions, not that you would need to, and the partition table is also replicated for increased fault tolerance. The reason that you convert to a GPT is because you need to have partitions which are greater than 2 terabyte in size. If you don't, then don't. To convert an existing disk to a GPT disk, I select my disk number 1, I right-click, and I select Convert to GPT. The reason I do that is if I want to have partitions which are greater than 2 terabytes in size. Part 2, Summary. In this section, we discussed spanning, RAID level 0, RAID level 1, RAID level 5, dynamic disk, and GPT. And this concludes Part 2 of Chapter 3.